Welcome to Get Your FRQ On. This is from the 2005 exam. It is question 6 and it is not calculator active. In the question stem, we are asked to consider the differential equation dy dx equals negative 2x over y, and then asked to sketch the slope field for this differential equation in part A. To sketch the slope field, we simply take the coordinates of the points provided and we plug them into dy dx and calculate the actual slopes. And then we draw little line segments with those slopes, and when we do that for all of the points provided, we get a slope field that looks something like this. All right, what's important to understand here is based on the differential equation dy dx equals negative 2x over y, whenever y is 0, we're going to have an undefined tangent line slope for this curve. So if we have a solution curve that is on one side of the x-axis, it generally is not going to jump over and also be on the other side. We'll either have a solution on the top or we'll have a solution on the bottom. We don't have one solution that crosses over and represents both halves of the plane. In part B, we are to suppose that f of x is a solution to this differential equation and that f of 1 is equal to negative 1. And then we are asked to find the equation of the tangent line to f at x equals 1 and use it to approximate the value of f of 1.1. Well, we're given dy dx and we're given the point 1 comma negative 1, so if we plug in 1 for x and negative 1 in for y, in other words, evaluating dy dx at the point 1 comma negative 1, we get a slope of 2. So the equation of the tangent line to f at x equals 1 would just be y plus 1 equals 2 times x minus 1. Now to evaluate or approximate f of 1.1, using this tangent line, we're going to replace y with f of 1.1 and then solve it for f of 1.1. Right, so using this approximation to approximate f of 1.1, right, replace y with f of 1.1, which we don't actually know, but we do know that x is 1.1, so I can put that in as well. And when we do the algebra, f of 1.1 is equal to 2 times 1.1 minus 1, which is equal to 2 times 1/10 minus 1, which is equal to 0.2 minus 1, which is negative 0.8. So f of 1.1 would be approximately negative 0.8 using this tangent line approximation. In part C of this question, given the initial condition that f of 1 equals negative 1, we are asked to find the particular solution to the differential equation f of x to determine it explicitly. All right, since this differential equation is separable, the expectation is that we will solve it using separation of variables. Failure to use separation of variables or using a different method very often will cause you to not earn most, if not all, of the points for this part of the question. All right, we take our equation dy dx equals negative 2x over y. Separate the variables, we get y times dy equals negative 2x dx. Take the indefinite integral of both sides. The indefinite integral of y is 1/2 y squared. The indefinite integral of negative 2x is negative x squared plus the c. We don't need a plus c on both sides. You can just have the plus c on one side. Typically it's on the side with the x. Since we're going to be solving for y, it's just easier to do it that way. All right, and then we have this initial condition. We're going to use the initial condition to find a specific value of c that will get us this specific particular solution where f of 1 will equal negative 1. All right, so if I plug in negative 1 for y and 1 for x, I get 1/2 of negative 1 squared equals the opposite of 1 squared plus c. So I get 1/2 equals c minus 1. And if I add 1 to both sides, we get c equals 3/2. So for this specific initial condition, we would use the value c equals 3/2 in this equation right here where we have the plus c. Right? So continuing that with c is equal to 3/2, we can now go back and explicitly solve for our function y. We know 1/2 of y squared is equal to negative x squared plus 3/2. If I multiply both sides by 2, we get y squared equals negative 2x plus 3. Then we take the square root of both sides. And remember, when we put the square root in, we have to write plus or minus because we don't know yet which one of those we actually need. So at this point, we know y is one of those two functions. It's either the square root of negative 2x squared plus 3, or it's the negative square root of negative 2x squared plus 3. This is where that initial condition gets used again. Since f of 1 is negative 1, we have to guarantee that the solution we choose gives us negative 1 as an output, and that is only going to happen if we choose the negative version of y. So our particular solution here, y, is f of x equals the negative square root of negative 2x squared plus 3.